Hamburg's port is vital to the city's economy, with 92 million tons of goods transported through the port annually. Cargo carried by trucks accounts for over 50% of this volume, with trucks driving more than 172,000 kilometers in the port on a typical workday. With kilometers driven and vehicle greenhouse gas emissions on the rise, a way needs to be found to reduce emissions from trucks which result from stop-and-go traffic. At the same time, improving traffic flow for trucks would mean fewer delays in transporting goods.
Our goal is to create efficient and sustainable traffic management in the port while ensuring road safety. One way we can achieve this is by optimizing our traffic lights so we can reduce delays for trucks, and this will help to reduce the environmental impact.
The Green for Transport initiative, launched in the Port of Hamburg, is an innovative approach to sustainable traffic management. A unique public-private collaboration between the Hamburg Port Authority and leading smart mobility providers. The project focuses on implementing intelligent transport systems in a high-volume area of the port to minimize delays for cargo-carrying trucks. As a proof of concept, Green for Transport conducted a 5-month pilot phase in the Katwijk area of the port, involving 60 trucks and 2 traffic intersections. The trucks were equipped with onboard units from NXB and Technolution and roadside units from Unex Traffic, which were installed at the 2 intersections. The centerpiece of Green for Transport is the implementation of V2X technology, which enables the real-time communication between onboard units in vehicles and roadside units installed at traffic lights. V2X technology makes it possible for a traffic light to detect an approaching cargo-carrying truck, designate the truck as a priority vehicle, and extend the traffic light's green phase to enable the truck to pass through without having to stop. One feature that makes the Green for Transport V2X implementation unique is that the traffic lights can detect a convoy of 2 or more trucks and extend the green light phase within the maximum possible time window until all the trucks have passed through the intersection. This keeps truck convoys moving and reduces greenhouse gas emissions from stop-and-go traffic.
Thanks to our local logistic partners who used our system in their daily operations, we were able to collect representative data from our Green for Transport pilot project. The findings from our evaluation of the data demonstrated that intelligent transportation systems reduced delays for trucks and reduced vehicle greenhouse gas emissions.
The HBA and its partners have invested a great deal of time and resources into Green for Transport, and there have been many challenges along the way. This includes regulatory hurdles, implementing technology and standards which are constantly evolving, but also educating our many stakeholders.
The successful deployment of the Green for Transport project in the city of Hamburg had shown excellent results, and it demonstrates how the cities, the environment and the economy can benefit from the adoption of the cutting-edge intelligent transportation system. I would like to highlight here that a project of this scale and complexity would not be possible without a close collaboration of a forward-looking government and innovative companies. With Hamburg showing the way forward, we hope this result will be duplicated in many cities around the world.
Green for Transport positions Hamburg as a leader in innovating for intelligent port transportation. With Green for Transport as a key milestone, the goal is to have total traffic management optimized traffic lights featuring real-time communication with road users implemented throughout the Port of Hamburg by 2025. This will make it possible for traffic in the port to one day be completely carbon neutral.
Until it's replaced, the Smart Bridge project has installed more than 500 sensors on the Kilbrandbrücke to determine its condition. This sensor data, in combination with a 3D scan of the bridge, creates a digital twin that can tell us the temperature, amount of rainfall, and other factors that would affect its structural integrity. It even has cameras to monitor itself. You can see these on the tablet as we drive over the bridge.
They turned the bridge into a robot?
Not quite. But because the sensor's measurements are monitored by intelligent algorithms, it can almost tell us how it feels in real time. This makes inspection and maintenance much more efficient, and it can even predict problems that haven't yet occurred. In the past, the bridge would have to be closed for a full inspection, which is a problem because it's an important artery in the port network. Now, we're entering a new era of intelligent infrastructure maintenance to make sure that the Kilbrand survives until the end of its life.
So first of all, almost all terminal processes are powered by electricity that has been produced through sustainable means, so wind, solar and hydro. A lot of power is needed to transport heavy containers, so getting that from renewable sources is already a big step in sustainability.
I see.
Now, there are still some processes that cause CO2 emissions, and these will soon be converted into electric. But for the time being, we're offsetting our emissions through climate-friendly projects, certified with a gold standard.
Das Verkehrszeichen Andreaskreuz an einem Bahnübergang bedeutet, dem Schienenverkehr Vorrang gewähren. Damit ein Autofahrer den Bahnübergang besser erkennen kann, bauen wir ein digitales Andreaskreuz. Es übermittelt über den Funkstandard V2X und Mobilfunk mit Backend Cloud die Information, ob der Bahnübergang geschlossen oder offen ist und wann die nächste Änderung kommt. Das Fahrzeug empfängt die Daten. Eine Anzeige zeigt dem Fahrenden an, dass er sich einem Bahnübergang nähert. Der Fahrende wird informiert, ob man über den Bahnübergang fahren darf und wie lange es so bleibt. Fährt ein Zug vorbei, so kann das digitale Andreaskreuz auch eine entsprechende Warnung absetzen. Dadurch werden Bahnübergänge besser wahrgenommen, der Komfort erhöht und Unfälle vermieden. Über eine App auf dem Smartphone werden auch Radfahrende und Fußgänger informiert. Bei einem Bahnübergang im Rangierbereich könnte zukünftig das Navigationssystem des Fahrzeugs die Daten auch dafür nutzen, um bei längerer Schließung der Schranke eine neue Route zu berechnen. Das kann sogar Leben retten, wenn ein Krankenwagen auf diese Weise wertvolle Zeit gewinnt. Das digitale Andreaskreuz ist die Strategie zur technischen Sicherung aller Bahnübergänge, unterstützt das autonome Fahren und macht die Mobilität intelligenter.
First of all, it's all about organization, right? We're driving such big trucks, so in urban areas where space is an issue, it's especially important to know who is coming in, when they're coming in, and for how long. So there can be a spot for the next delivery.
It makes sense.
For years we've already been using a system called Port 24/7, but the goal is to transform it into Cargo 24/7. Which would coordinate slot booking between port terminals in hinterland regions. Then my work trips could be scheduled to account for traffic and a schedule for other trucks. This would not only free up parking, but also decrease wait times for trucks during container delivery, leading to better traffic overall. Well, it's going to be developed into a fully automated parking area called pre-port parking. Since it's right in front of the terminal, trucks can park there during peak traffic hours and then enter the terminal for unloading at the optimum time, leading to even less congestion.
Automated parking? What do you mean?
The trucks are all communicating with each other through a centralized system, so they can be parked much more precisely to maximize parking space. That way, if I miss my delivery slot because of traffic on the Autobahn, I can conveniently park there until the next slots open up.
Every day, around the world, millions of shipping containers are in motion, an incredible achievement of logistics, coordination, and communication. But legacy data systems and manual document handling cause friction that costs both time and money for businesses and people throughout the supply chain. TradeLens is a digital shipping platform powered by blockchain that enables unprecedented transparency, collaboration, and efficiency in global supply chains. TradeLens provides control and management of shipping data and supplies innovative apps to every stakeholder in the supply chain: shippers, freight forwarders, intermodal operators, ocean carriers, ports, terminals, authorities, financial service providers, and more. To illustrate some of the ways TradeLens enables collaboration and reduces friction, let's follow a shipment of laptop computers from inland China to their final destination along the west coast of the United States. Using the document sharing capabilities of TradeLens, the shipper can submit shipping instructions to the carrier, who accesses the information to draft a bill of lading for the shipper's review. Once a final bill of lading is verified by the shipper and carrier, TradeLens makes it accessible to the customs broker, the authorities in the port of entry, and the cargo owner at the destination. All along the supply chain, access to shipping data and information is managed by TradeLens' sophisticated permissioning model that controls who can add, view, and update information at each stage of a shipment, and provides a blockchain-encrypted audit trail of all critical actions. The benefits of TradeLens really deliver when the planned turns into the unplanned. Due to a sudden shift in inventory demand, the shipper requests the cargo be diverted to its distribution center in eastern US, near Savannah, Georgia. Following the request, the shipment is rebooked on another vessel, requiring a change to the manifest and a reissued bill of lading. Using TradeLens, the carrier can create and publish the amended bill of lading to the platform for all permission parties to see. At the customs broker, the new information is updated into the shipment's import declaration for timely submission to US Customs. With TradeLens, any permissioned party can find the shipment through a range of search parameters, such as equipment number, bill of lading number, booking number, and more. Viewing the transport plan, they can see the key milestones on the shipment's timeline. TradeLens supports more than 120 planned, estimated, and actual events, all tracked instantaneously, giving detailed insights up and down the supply chain. In the case of this shipment, supply chain partners downstream are notified of the vessel change and are able to coordinate and manage the impact of the destination and timeline changes. Global trade is an incredibly complex system, but with TradeLens and blockchain technology, we now have a trusted solution to support industry-wide innovation. TradeLens. Trade made easy.
The project I2 Panama aims to rig ships and ferries with sensors connected to the Internet of Things. This data can be used for a variety of purposes at different parts of the logistics network. For example, travellers waiting for a ferry to arrive could get real-time data on whether it will arrive on time, or conditions that could cause potential delays, or a ship's electricity consumption could be tracked to optimise the use of onshore power supply.
Welcome to the drone port tour of the 2021 ITS World Congress. In this tour, we'll take a glance at some of Hamburg's most advanced drone projects and see how they can improve safety, security, sustainability, and general quality of life in urban environments. More and more drones take to the skies, flown not just for recreation, but in industrial sectors as well. Systems need to be in place to validate and regulate this increase in unmanned air traffic in order to maximize the safety of everyone in the city.